Alright, hey guys, I want to go over the solution to 2.2. So in part A of 2.2, you have, let's see here, you have 6 jars of peanut butter and 2 jars of jelly. Okay, and so let's go ahead and graph that. You see that if I go ahead and put peanut butter on this side and jelly on this side, alright, 6 jars of peanut butter is about here, 2 jars of jelly is maybe about here, and I have the endowment point 6, 2. Now, how do I find the endpoints on this? Well, what I do, I go ahead and imagine, remember that jelly is selling for $6 a jar and peanut butter was selling for $4 a jar. So if I sell 2 of my jelly jars, I get $12. With $12, since peanut butter is $4 a jar, I can buy up to 3 more. So the maximum possible amount that I could buy would be 9 jars of peanut butter. Doing the same thing here, if I sell 6 peanut butters, how many more jellies can I get? I get $24. How many more jellies will that allow me to buy? It'll allow me to buy 4 more. So I should have something up here at 8. No, 6. Excuse me. 2 plus 4 is 6. And I create this line here. That's my budget constraint. If you look, the slope is negative 2/3 or 2/3, which says the opportunity cost of peanut butter is 2/3 of a jar of jelly. Okay, and now in part B, we are going to go ahead and ask what happens when the price of peanut butter increases to 6. So we can do this relatively easy mathematically. Remember, we still have the endowment point that's still accessible for us. But if I go ahead and now sell 2 jars of jelly, I can only buy 2 jars of peanut butter. So this takes me down to 8. And also, I can, if I sell all 6 of my jars of peanut butter, it allows me to buy now, what is that, 6 more jars of jelly, because they're the same price now. So this comes up here to 8, and I have this new line here with a slope of -1, or an opportunity cost of 1. Okay? Now, we're going to go ahead and do this mathematically. This is the B portion. And so basically what it asks us to do is write down the equation representing the budget line. So here's what my equation representing the budget line. Remember, it's always income is equal to expenses, or expenses equal to income. So in general, I'll have P1E1 plus P2E2 equals P1X1 plus P2X2. Well, we do know some of these, right? We do know that, let's see here, P1, the price of peanut butter, is 4. So everywhere you see this, we're going to plug in a 4. And how much peanut butter did I have at the beginning? I had 6 peanut butter. And P2 now is, how much was P2? It was $6. So everywhere I see P2, I put in 6. And how much jelly did I have? I had 2. Okay. So now this is going to turn into 4 times 6 plus 6 times 2 is equal to 4x1 plus 6x2. This implies that looks like that's what, 24 and 12, that's 36, is equal to 4x1 plus 6x2. And finally, if we go ahead and rearrange it so that we can graph it in y equals mx plus b form, you'll notice the x2 is kind of like our y. Alright, so let's go ahead and get the x2 by itself. We'll move the 4x1 over to this side, and I'll have 6x2 equals 36 minus 4x1. If I divide by 6, I'll have x2 is equal to 6 minus 2/3 x1. And you'll notice that x2 equals 6 minus 2/3 x1 is exactly this original line that we drew. Finally, if we went ahead and did it under the new prices, where they're both equal to $6, it's not too difficult. I just change P1 here to be 6 everywhere, and I'm going to end up with, let's see here, let's restart. I'm going to end up with 6 times 6 is 36, plus 12 is 48. So I would have 48 is equal to 6x1, because it's no longer 4x1, 6x1 plus 6x2, and this implies, once I solve x2 all out for itself, is equal to 8 minus x1, which if you notice is exactly this second line that we drew here. Alright, and that's 2.2. Alright, hey guys, I wanted to run through the answer to 2.4 with you guys. Let's do part A first, which is asking on a three-dimensional graph, illustrate a budget constraint when your economic circumstances are defined by price 1 equals 2, price 2 equals 6, price 3 equals 5, and your income equals 20. And you can label the intercepts. So we're going to start out with a three-dimensional graph. It's kind of tricky, and on a test I won't ask you to graph in 3 dimensions, but on the homework you can kind of figure out how to do this. This is x1, this is x2, and this is x3. Now, let's go ahead and mark the intercepts of the budget set. So if I were to buy all x1, well, I would have $120 divided by $2, and so that would be a total of 60. In x2, it's $6, so 120 divided by 6 is 20 if I were to buy the maximum amount of x2. And if I were to buy all x3, it's 120 divided by 5, so that would be 24. And then I go ahead and connect these with lines, and I have a three-dimensional budget set. Remember, it's this sheet is the budget set, and then underneath is the choice set. Okay, now let's see here. What is the opportunity cost of x of x1 in terms of x2? So the opportunity cost of x1 in terms of x2 is merely the slope of this line. The slope of this line is going to be p1 over p2, which, if I look at that, it is going to be 2 over 6, which equals 1/3. And of course that is negative. Because the slope is negative, the opportunity cost, though, would just be 1/3. And then it asks, what is the opportunity cost of x2 in terms of x3? So we're looking at the slope of this line. Now, just in the same way this is p1 over p2, this is actually p2 over p3, which is equal to 6/5. Alright, so the opportunity cost is 6/5. That means in order to get one more x2, I have to give up 6/5 of an x3, if that makes sense. So that's where I'm at as far as the opportunity costs. Now, we have an income change that falls to 60. What happens then? Well, basically, all of these intercepts go down by half. So I can only buy 30 of this, I can only buy 10 of this, I can only buy 12 of this, and my choice set is decreased in the same fashion. Does your answer to part A, the slopes, change? Well, it's pretty easy to tell by looking at this that the slopes don't change. Remember, the only thing that can change the slopes is changing the prices. Changing income is not going to change the slopes. Alright, next, let's see what happens. Let's take away this income change. Let's see what happens if the price of x1 rises to 4. So basically, if the price of x1 rises to 4, I am only going to be able to afford 30 of it. These intercepts will stay the same, and I will have something that looks like this. Now, as you can see, these slopes do in fact change. Okay? And you can probably figure out the new slopes here if you wanted to. This slope, though, if you look at it, doesn't actually change because it's the same. Even though my red line looks like it came off of the brown line, it actually is the same as the brown line. Finally, write down the equation that represents your picture in 2.4a. So this is part B. Okay. It says we need to write a budget line basically for this. Well, this is not too hard. We know that the budget line is P1x1 plus P2x2. Well, there are 3 goods, so it's plus P3x3 equals income let's go ahead and fill in the requisite numbers. If I recall, P1 was 2, so it's 2x1 plus 6x2 plus 5x3 equals 120. Now, finally, if a new good x4 is invented and is priced at $1, I just go ahead and put that in there. 2x1 plus 6x2 plus 5x3 plus x4 equals 120. Neither of those are graphable because, excuse me, this one's not graphable because it's in 4 dimensions. This one is graphable. I just graphed it over there. It's really hard to visualize in 4 dimensions. All right.